Once you're done, you can pull out your book, show it your best nitrogen, or in this case, nitrogen gas. That one, excellent. Lewis diagram. Leftover from last day. It's that one. It should be N2. You just have N. But where's the second N? You should have this from last day. Put that away. You've got your N. There we go. What have you done? That's amazing. Where's it? No. I'm amazed though. Where's N2? There it is. That one's looking good. Okay. N2. Yep, got it there. N2 looking good there. Do you have your N2 from last day? Yeah, these are all from last day. Oh. You have too many Oh, you haven't gone far enough. You haven't gone far enough. Do you have N2? Yeah. Well, you have 2 lone pair electrons, and currently they wouldn't be happy. Yeah, there you go. Excellent. Got the spot from last day. Excellent. And excellent. Ooh. We're doing fairly well. Hold it. I did. It was over here. Still finishing up. Do you have it from last day? Are you restarting this, or do you have the notes from last day? Do you have this from last day? Like if you flip back, this was up last day, so you should already have it down. There you go. Yeah, so we're just going over those. You don't have to restart it. No, that's okay. No, you've made them separate. They have to be joined. So step 1, add up all the electrons. As you did here. And then you put the central atom in the middle. Which one's going to be the central atom? Yeah. Well, no, there's 2. You got to pick one then. Excellent. Then bond it with the other one. Minus that many electrons away. Why did you do double bonds? You don't start off with double bonds. You end up there. Well, show the bonding, because now they look separate again. You've just given them all electrons. You need to count them away. And the first thing you do is you give them a bond between them. Yeah. Do you have the list of erase all the other things you did. Just the one bond. And then what's the next step from last day with our instructions? Do you have that? What's step 2? Oh, we don't have to worry about charges. Next step after that. did that. What's the next step?
Add electrons to each atom to give each an octet.
Right. Central atom last. So you said this was your central atom?
Yeah.
So you give that one an octet. And then minus all the ones you used up.
So I used up like
2, 4, 6.
6.
Well, that was already, you already accounted for that with minus 2. So now minus the 6.
So 8 minus 6.
Yep.
2.
No, you have to act like you have to do it. Okay? And then you put the last 2 in the central atom.
1, 2.
No. Each line is 2 electrons. Yep. So if you're doing the German method, every time you draw a line, that's 2 electrons. Okay? And then you minus that 2 and you're at 0. Excellent. Now, see, because before you were just adding tons. Now you've had to stop. Now, are they both happy? Which one's unhappy? So what will you do in order to make them happy? Yeah. And then see, check if it's happy, and then keep doing that if it's not. Almost done? Oh, God. Sir. I'm going to go through this one then. So, first one, how many electrons do we have? 10. Pick one to be the central atom. Which shall it be? The left. So this one. Okay. So we minus 2 because we gave it a bond. That's the central atom. Where do we put those electrons? On the outer atom. So 1, 2, 3, 4, 5, 6. Once I filled up that one, I put the other ones on the center atom. And that's how I know when to stop. In some cases, when you end up with too many bonds or too many electrons, it's because you just keep adding electrons. You're doing this so you know when to stop. Now, it's not happy at this point, so what did everybody end up doing? Triple bond. So we go, aha, these could become a bond. 2, 4, 6, still not happy, so those could become a bond. And we end up with a triple bond nitrogen. I'm going to draw that a little more nicely. And so that's how we get triple bonds. We are keeping track. If you're not doing this, please do this. This helps you keep track of where all the electrons go, how many to add, and where to stop going. Next one, we did C2h6 No3 minus 1. So let's start off with C2h6. Now this one's a little funky because you either have to adapt and do it the other way with just like looking at it and doing the individual ones, or you accept that there are 2 central atoms. Yes. Okay, so if we have 2 central atoms, how many electrons do we have for the carbon? And from the 6 hydrogens, so we have a total of 14 electrons. We want to do it via central atoms. And then we put the hydrogens all around and then bond them. It's all one molecule, so you can't make 2 separate things. Then we just count 2, 4, 6, 8, 10, 12, 14. Done. Now, sometimes these organic structures lend themselves really well to doing this with individual Lewis dot diagrams. So, for example, in this one, we have 2 carbons and 6 hydrogens. So for that, I would just make a carbon. Come on. No. And let me make my hydrogen. Because sometimes it's a little easier to play with them like they're Lego pieces. So I need 2 of these carbons, and then I need 6 of the hydrogens. Now, one of the rules that will help out, carbon is the backbone of any organic chemistry molecule. They're always going to be joined together. And hydrogen only likes 2 electrons. So for it to be a full one, we have to do this. And then we just start piecing them together where they would like to bond. If you start off with the right number of hydrogens and carbons, and their Lewis dot diagrams are already complete, then all of the electron counting will take care of itself. And everywhere that you've joined them into a pair becomes a bond. So your final one looks exactly the same. And this is one of those cases where looking at it and doing the individual Lewis dot diagram separately might be a little easier, because it doesn't have a central atom. And that method really works for atoms that have that. So you just have to explore. There's one question like this that's also in your book. They give you the skeletal structure, though. Questions on this one? Okay. Hold it. Did you have your hand up? Nope. Next, did I skip one? NO3. I'm probably right in your way, I just realized. So we have NO3 minus. Now, looking over some people's shoulders, this -1 is what I'm putting there to remind myself, if I have a -1, what do I have to do to the number of electrons? +1. How many electrons do we have from 3 oxygens? 18. And from nitrogen? 5. 5 plus 18 plus 1? 24. Now notice, almost every single time we have an odd number of electrons, the molecule ends up charged. Curious. It's almost like those suborbitals want to be full. Which is the central atom. Put the other ones around. Join them all at once. How many electrons do we get rid of? 6. Now, which ones do we start giving electrons? Outer ones. Or oxygen. I did see a few where people really want to start here. We ignore nitrogen. We start on the outer rim planets. 2, 3, 4, 5, 6. Minus 6, 12. Oh, and I've got 2 left, and I did 6, so that's going to be minus 6, 6. Minus 6, 0. Everybody happy? What should I do? Nitrogen doesn't have. So what should we do with nitrogen? Double bond it. Let's go with this one. Any particular left, right, top? No. Double. So I had two electrons away, slid them into a bond. Did I keep going? Why shouldn't I keep going? Jonah? Oh, how many electrons does nitrogen think it has? 8. So that's when we stop. Guarantee somebody in one of my 3 classes will do this. And then they'll get really excited, like they figure out the secret of the universe. And they'll start doing this. And then they'll think about it for a moment, and then they'll go, no, that's right. And then they'll move on. But if they're really uncomfortable with those low electrons, they'll do this. Quad bond, which does not exist. There is no quad bond. And nitrogen now is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, all 24 electrons of nitrogen. Nitrogen is, again, like last day, too many slices. Too many slices. So that's why you stop. Once it's had enough, you don't need any more. Now the last one, I'm going to give you the overall structure. I want to come around and see what you've come up with. Again, carbon, these are the central atoms. Carbon is the backbone of organic chemistry. Yes. Oh, sure. Now, I'm just going to single bond them. That doesn't mean they are only single bonds, but you should set it up like this. Now, one thing you can do is you can set up the Lewis dot diagrams of hydrogen and carbon and oxygen, and then just play around with those and put them in each section and give them the proper amount and see what happens. Or you can count the total number of electrons and do the minusing with using those at the central and just see what you get at. Both methods kind of work. You kind of have to adjust both methods in order to get it. This is sort of like you squint at it and you go until it feels right. Organic molecules, I said carbon is the backbone, so whenever you get one of these, these are always joined together. And that's what makes it an organic molecule. And just to emphasize, organic in this class means something a little different than the grocery store. Organic just is carbon. I was in third year organic chemistry working for my uncle who owns a turkey farm. And a lady called me and asked me if our turkeys were organic. And I said, of course they're organic. They're turkeys. She said, no, are they organic? I said, well, the bones aren't organic because they have calcium in them. And I guess the salt wouldn't be organic, but most of the turkey is organic. And then she got very angry with me. Because in chemistry class, all it means organic, it means it's made with carbon. That's all it means. In the grocery store, it means it has a specific label, which apparently means a lot of different things. How many electrons does that oxygen think it has? Each bond has 2. No, this oxygen, how many does it think it has? It thinks it has 10. So you're actually on a good track there, but there's some, I don't know if you have the total number of electrons wrong. You're missing an oxygen. Oh, there's 2. Yeah. Ooh, you're on the right track, but it's not quite 2, 4, 6, 8. Oxygen really hates 3 bonds. That's your hint. But you're doing clever things. On your way. Can I see your previous ones? Because I didn't get to see you because you were on the computer. Like the previous ones, the ones from last day. What book is this? Oh, you don't do notes in your head. No. I can see you've got the structure up. Why is your email open? Put that away. You don't need that. Put it in your bag. Oh, hydrogen has way too many electrons. How many does hydrogen want? It wants two in total. It has one, but it wants two. And so if you give it a lone pair, it's going to be deeply unhappy because now it has three. Yeah, so hydrogens you're going to want to leave alone. Oh, that looks good. Yeah. Until it gets to 8, yeah. But do it on the outer ones first. So think of carbons as the central. Oh, yeah, perfect. Yeah. CO2 looks good. And then N2, well, you started, but you crossed it out. Did you go on the next page? Oh, you should do all of. Do you not have separate books? Yeah. Just go to the store and get some more. Well, maybe get one because you're running out. I think that is you are like second to last step. One of those atoms is unhappy, but their setup is great. It's carbon. Ooh. Hold it. That oxygen should be there. That one, that top one. It's on top of the carbon. And have you been counting your electrons away for this one? Well, let's go through it again because you have way too many electrons here. You've overcounted because how many are hydrogen happy with? 2. Hydrogen's an exception. It only wants 2. Yeah. Yeah. And I would go back. How many electrons did you have originally? Like just counting it up. Okay, let's start a new one with 24. And erase all these lone pairs. Okay, you got 24. Now you have to minus 2 for every bond there is. How many bonds are there? No. Every bond. Yeah. Every bond is 2 electrons. Yeah, so you'd minus what? 14, yeah. So you only have 10 left. Now you'd put them on the outer atoms to give them an octet. The outer atoms are things that require an octet that aren't carbon. So not hydrogen. How many does hydrogen want? And how many does it think it has? 2. So, yeah. Next, minus those 4. Yep. Excellent. Minus 6. Now, are there any central atom not have an octet? Right. You can't. Oh no, you have 0. You can't just go. The electron police will come after you because you're stealing electrons. So what can it do to get more? Oh, that's very clever. No. Your instinct is correct. No, your instinct is correct. I'm going to give you a hint. Oxygen hates having 3 bonds. Is there a way that you could do that without giving oxygen 3 bonds? No, that's not the one that's... There's no lone pairs you can use. What about that oxygen? Yeah, there you go. Now they both only have 2. That you would give oxygen 3 bonds, and oxygen hates that. And you don't know. We haven't done organic chemistry yet, so you don't necessarily know that. So these are like secret rules. No, why didn't you give your outermost atom a full octet? Yeah, take those away. No, Chet, tell him. Explain to that man. Oh, that's good. Yes, it would. Because oxygen hates having 3 bonds. Is bad. Yeah, oxygen just really doesn't like that. That looks good. Yeah. That looks good. That's awesome. No, that's perfect. Oh, I have no idea. You should have run out. Oh, 24 minus 14 is, first of all, 10. You're not counting, and then you minus 7, and I know you don't minus 7 at any point. So you have miscounted in some way. Let me just go through that. So minus, get your 10. Okay. And then you put on probably 4 there, right? So you'd minus that 4. And then you put on 2, 4, 6 here originally probably, right? And then you made a double bond. So you'd minus that 6. And then you'd get to 0. Yeah. I don't know how you got 7 at one point unless you were counting some of these as 1 electron.
I think I just missed this stuff when I was looking too.
Oh, okay, okay. Because you ended up in the right spot. Yeah. Oh, the good.
How many electrons do you have?
That man is helping him. Where is it? There it is. No. Not a bad instinct. Your instincts are correct. First of all, why is that there? You should put those on the outer atoms first, so you never get into the central atom. And 2, the secret is oxygen hates having 3 bonds. So you wouldn't use that oxygen to give it an extra bond. Oh, you can't take away. You wouldn't put the double bond there. Carbon has no lone pairs to give. Where's another oxygen that has lone pairs to give? Yeah. And then you take away one of its lone pairs. Now you're good. Oh, that would never have a double bond. Hydrogen is happy with 2. Well, you took it from there, but you actually never erased one of those lone pairs, so you ended up... You should not erase one of those lone pairs. When you originally put it there, you should have, but when you took it away, you fixed it again. Yeah. And you did your counting. Organic chemistry. Quantum. I almost got kicked out of a organic food store in downtown Victoria. Well, I did get kicked out, but only by my wife. Because they had a large sign that said organic salt. Salt was like, that's literally the one thing that's not organic. It can't be. It's a literal rock. Like salt is a rock. It can't be organic by any stretch of the imagination. And my Lisa just wanted to buy some nice hummus, so she told me to leave the store before I attracted too much attention. They sell excellent hummus. All the places that say their stuff is organic usually do. Okay, so we have 2 carbons. Oh, and I just got carried away there. And we have 4 hydrogens and 2 oxygens, and there's no charge. So how many electrons from the 2 carbons? And from the 4 hydrogens? And from the 2 oxygens? 12. So 8 plus 12, 24. Then we have to minus 2. Got to put my glasses back on. Every bond we have. So we have 1, 2, 3, 4, 5, 6, 7 bonds just from setting it up. So 7 times we have to minus 14. And then how we adjust our method for a more complex molecule like this is we go, well, these carbon in organic chemistry is the central atom. We're going to put electrons on it last. So we fix up everything else. Hydrogens are happy with 2 electrons, and they're all bonded, so we can leave them alone. But this oxygen needs 1, 2, 3, 4 more, and 2, 4, 6, 8. Now that oxygen is fine, so I'm going to minus those 4. And this oxygen needs 2, 4, 6. 1, 2, 3, 4, 5. So now we're out 2, 4, 6, 8, 2, 4, 6, 8. Anybody unhappy? That carbon right here. Now we can't just give it more. The reason we're counting down is so that we don't do that. It has to bore. Now some of you very cleverly, and I can't say you did anything wrong because you didn't know this yet, went like this. And the reason you can't do that is oxygen just gets really upset. It doesn't like having 3 bonds. To the point that if they make molecular models, like these ones, oxygen's always red in molecular models. It only has 2 spots for bonding. They don't even give you other spots. Oxygen just doesn't do that. Or something like carbon, always can have up to 4 spots. Carbon will never have 5, no matter what. And these are things that you get used to, but also the trick is you can see that in the original molecules. How many lone electrons does hydrogen have? 1. So it wants to bond in 1 spot. How many lone electrons does carbon have? 4. So it wants up to 4 bonds. How many lone electrons does oxygen have? 2. So it has 2 bonding spots. Now they can have less than those bonds, but they can never have more. They don't want to have more, and that's where those numbers come from, and that's just how they react. So that was, this was a clever thing, but I cheated by not telling you about that rule. Pardon? So we take away, we take away 2 electrons from there, from the other one that has them, and then we can make it happy because that one now only has 2 bonds. It's fine. This one has 2 bonds, that one has 2 bonds, all is well. Okay. One little section of notes. These are now our exceptions to our octet rule. So I told you in octet, every atom wants to have eight electrons, except for most of the periodic table. Because hydrogen, as we already know, is stable with 2. On our periodic table, beryllium, and we can convince it to undergo some covalent bonding even though it's a metal, is happy with 4, 2 bonds. Boron, on the semi-metals, so it can definitely engage in some covalent bonding, is stable with 3 bonds, or 6 electrons. And everything from phosphorus onwards will not demand an octet, but if it's a central atom, it can have more than 4 bonds. It can have 5 plus. 8 is a common amount for them to do. What they do is they end up dipping into their D shells, and they just use those electrons for more bonding points. Yes? Oh, yes. You're going to do some examples in a moment. Aha. Yes? Oh, because they can. Like they have them available to them. So from phosphorus, what energy level is this in? It's in P. What number P? 3P. 1s2, 2s2, 2p6, 3s2, 3p. Now it hasn't filled up the 3D, but they are in the 3rd energy level, and so they actually can use the 3D for some of their electrons. So that because they're in the third energy level, they have access to the 3D orbitals. And they can start doing some funky things with the shape. Because you know the shape of the d orbitals are looking like butterflies. They can now do stuff with that. They have access to it because they're in the third energy level. All the outermost elements are going to generally conform to having only 8 electrons each. It's the octet rule. But the central atom, in our rules, one of the things I say at the end is any excess electrons you place on the central atom, they will take them if they're forced to, if they're phosphorus or above. So this means in now our instructions where it says make sure each atom has an octet. If it's hydrogen, you make sure it only has 2, as we've been doing. If it's beryllium, you make sure it has 4. If it's boron, you make sure it has 6. Oh no, on a test I'd give you a question like these. Anyway, there were some hands up. Yes? Yeah, because it fills up its S shell. And it only needs 2 electrons. Sorry? Yeah, that you just said the reason, because it fills up its shell. Because what shell is hydrogen? What shell is hydrogen in? S. And so once it fills up that shell with 2 electrons, it doesn't need another 6. It's done. Beryllium is happy with 4 because what it does is it fills up its first shell and uses them and then just fills up this shell, the S. It doesn't even bother going to the 2p. And then it's happy. Boron is just weird. I have no decent explanation, but it's fine with 6. Yeah, I don't have a decent explanation. Not one at this level, anyway. So, these are the exceptions. Let's not do... These are in the wrong order. Make this one last, because that one's just more like fun. BF 3, PCl 5, SF6, CO3 minus 2 is just doesn't even use any of the exceptions, just a classic one. And this is just a practice one, doesn't use any exceptions, but BF3, PCl 5, SF6 are all good practice. Ooh. Sorry? Oh, yeah. That you can breathe in. We can't get it. I asked. They won't ship it to the island. And apparently there's like safety considerations. You're not allowed to breathe it in unless you've had like, because it's a very dense gas. If you breathe it in, it can actually stay at the bottom of your lungs. It doesn't want to come out. So you have to like know how to make sure you eject it properly. And like high school chemistry teachers are known to kill themselves in demos. So yeah, there's a methanol flame test I used to do all the time. And now I do it a different way. But the reason we can't do it anymore is because American teachers kept burning themselves. Like badly burning themselves. Because something would catch on fire and they would take the bottle of liquid they were using and use it to pour it out. And it was full of methanol, and then they would light everything on fire. No. You are not, technically in BC, you are not required to have a chemistry degree to teach chemistry. It is a teaching area, but once a school hires you, they can hire you for anything. I taught Math 9 in the first year I was here. For no other reason than they needed a Math 9 teacher, and I was a science teacher, so they're like, yeah, hey, I don't have a math degree, but it's Math 9. I mean, come on. But technically, they could make me teach History 12. Well, bad. I think it would be an amazing class, to be honest. No, a lot of truth would be happening. BC. One's good. But in the states, depending on the state, so I don't want to give the impression that they're all like this, but there are many places where the only thing you do need to have a degree in BC. In some states, you only need to have graduated high school. There was a thing started by Bill Gates called Teach for America, where they would get graduates, so university graduates to teach, who had graduated in literally anything. So you didn't learn how to teach, but you might have graduated in marketing. And they would say, teach for a year and we'll pay you. The idea was that you didn't have to know how to teach, you just had to be really excited. And you didn't have to know how to teach chemistry. You just had to be excited about teaching. They would use a textbook. And so too many people who weren't aware of safety protocols were teaching chemistry, burned themselves, and now there's some demos we're not allowed to do. One of them has 8, maybe it's only 7 scientific papers about him. Well, he swallowed liquid nitrogen. Yeah, but liquid nitrogen, we will hopefully do it later. It's so cold. Have you ever seen sorry, I don't know why I took that off. But when you've put water on a really hot pan and it sort of dances around because the pan's so hot, your tongue to liquid nitrogen is that hot. So you drip liquid nitrogen on your tongue and it just dances around and you let it fall off. And it's like, look, I'm not freezing. Cool demo. I would never do it, but some teachers do. No, I would never let you do it. What he did is he forgot what he was doing and he swallowed. As we're going to learn later, a small amount of liquid, when converted into a gas, creates a large volume. This amount of water, about oxygen being 1632, 34, 35, so about 36 mils of water, that small amount, will make a volume of 22.4 liters, a balloon like this big, when converted to steam. That's why steam engines are so powerful. So once he swallowed that, that tried to expand very quickly in his stomach to multiple liters of volume. It burst open his intestines, his stomach, his throat exploded, like all sorts of bad things. He survived. And the surgeries were so unique and required so much intensive care, they wrote papers about how they did the surgeries. He's a very lucky person. Okay, these are challenge ones. Go through, do them. I'm going to come around, take a look. So start with these. These are standard. And some of these are just review. They're not doing the exceptions like CN. There's no exception in there. But just to practice your skills. These are some that I consider maybe just a little bit more challenging. They've got some charges in there. They include some exceptions or non-exceptions as well. See how you do with those. Do these ones first. Do that one last of the top. It's more similar to the last one we did. And then try some of those. Be there in one moment. I just got to check. We've got, today's Friday. Okay. And as well, while we're doing that, last day most people did not pick up their temperature. So if you've not picked up your temperature, you should come up and get that. quite done. Well, I'm not going to tell you. I want you to keep working through it. Ooh, that one looks good. Oh, no. No. Central atom is which atom? Oh, no, it is done. So you have to test every single one. Yeah. Yeah. So that's one of the exceptions to Octet. Octet, yeah. Ooh, that one is good. Oh, except for that dot. No, if that's a smudge, no, it's good. Oh, is he right there? No, it should all be in the central atom. One, two, three, four, five. One. Why do you only have 5 of them?
Oh, it's 6.
Yeah.
Okay, yeah, that's what I want.
Does that make more sense?
Yeah.
Yeah. That was lovely. Lovely. Is that done? Oh, no, no. Be confident. Is it done?
No.
Okay. Are you sure?
Yes, I feel like we're going to say yes, be confident in yourself. Yes.
Oh, that's good because it is done. Why is it done? Foreman doesn't have enough time?
Yeah. Only way up to 100 seconds.
It is 100 seconds.
Oh. Nice.
Ah.
Nice.
Yeah, and you ran out of electrons, didn't you?
8 electrons.
Really?
Yeah. Is it at 42, right?
2, 4, 6, 8, 10, 12. And you would have minused that off at the beginning. Did you account for that when you added the other one?
Yeah, I got
Minus
that
2.
one.
And then you went and minus 6, and you end up with 8. And you have 6, 7, 8, 9, 10. That seems like you have too many. 6 times 6 is 42, plus 6 is 48. Let me just do it up here, because it just feels like you have way too many electrons. So we have 6, 42, 48. We bond it 6 times, 2, 6, then we minus 12, which gives us 36. And then we have 6 times 6 minus 36. I end up with 0. Every single fluorine.
Probably forgot to minus some.
You probably forgot to minus some of those, because there's 6 electrons in every fluorine.
Yeah, because this should make sense. It's just for some reason I had a couple of extra electrons, so I
Okay.
probably just minus.
I'm gonna come this way again. I haven't seen these people off. I'm gonna go down here first. Oh, nice to meet you. Hold it. No, this is so far so good. Boron history, 3, 21, 21, 24. You minus, hold it. Why'd you minus 4?
I left me alone.
18, right? And then how many do you put in each oxygen? Yeah. How many went on that oxygen? 6. And then on that oxygen? And then that oxygen? What's 3 times 6? So minus that 18. This is why keeping track is so important. And then get rid of those 2, because you just added the rest of the Excellent. Now you can do something with that.
Can I see the sheet?
Yeah. Well, you have the same thing. Why do you have it? Why do you have it? I don't know. Is it? Aha. The common theme I'm seeing in there is not keeping the central atom as central. So the central atom is bonded to everything. So boron, all 3 bromine. Phosphorus, all the bromine. Sulfur, all the sulfur. All bonded to each other. Let's go back. Let's go back to the yes, the central atom, which is the central atom? I said leave that to last. Try again. Let's go. Which is the central atom? It's organic chemistry. It's got a carbon. There's only one central atom in organic chemistry, and that is carbon. You put the carbon in the center and everything around. I will be after I go through here, and then I'll come back around. Or you can compare with partners. Why don't yourself and Francois get together and compare answers? You've both been working. You've had similar types of answers. If one of you gets it wrong, that would be interesting. Excellent. Bond them all. And count up the electrons. That thing where you have carbon, how many electrons, hydrogen, how many electrons, 2 oxygen, how many electrons, add them up.
You know where the does the H just go here or does it go here?
No, just single bonds to begin with. Double bonds only if we have to. Okay, so single bond first. So give me a count of the electrons. I'll pop back. I'm just going to check down here.
Oh, is that good?
No, boron, normally without a carbon, you have to make a double bond because it makes you because boron is stable. You have phosphorus, you don't have phos, C2h6 No3, over 2 N is phosphorus. So it has more than 4 bonds. So these are and then
Right on. What's on each side?
oh, you're saying the same thing. What? You? Yeah? But that was carbon. This was chlorine. Think about it. But it's boron. And it's stable. So this is the exception. That looks good. This one, which is the central atom in this one? Oh, oh no, it's the P. Yep. You put phosphorus in the middle, you want everything to it. Fix that one. I'll come back. No, check this one.
Have you done NiTr yet?
No. I'll do that. Actually, I'm doing
Excellent. So you've got a total of 4. It has a -1 charge. Add an electron. Carbon is how many valence electrons in carbon? 4. You would say. And how many valence electrons in hydrogen? 1. And fix the oxygen too while you're at it. And now add all this up. Now this come up to a nice and take them away as you do it. So I would pick, don't do it evenly, be very delicate. But like, give it its complete opposite. Minus it and then go to the next one. Okay, so you used up 2.6, right? So minus that. That's it. Now give that one its full octet. Full octet. Now that one's happy. Minus those. Now you're out of electrons, you've used them all up. Is any atom in there unhappy? How many electrons do the oxygen contain? I'm just covering up the carbon so that we can count. Yeah, there it is. So they're not unhappy. They don't like having more than 3 bonds, but they only have 1 bond each of this. And they can even have another bond if they want, if you need it. Because that they don't like more than 2 refers to the number of bonds, not the electrons. They still want an octet. Is there any other atom there that doesn't have a octet? Carbon. How are you going to get an octet? You can't add 2 more. Where do you get it? Yeah. You don't take away 2. There you go.
That's why I just
Flip
did
over.
that actually. Cause the
Okay.
iodine can
Do
have
the next one. Now remember, boron is the central atom. Erase all this. Do it exactly the same way. Do your little accounting with electrons the same way. And make
cause
every
like
fluorine on the
I
board.
did
And
it
then do
similar
the
to
outer
the
atom
snow
the same
and
process.
I had 2 electrons left over and like
It's stable 3 bonds. That's okay. But it will, it, it's essential atom. You'll bond it with all those. But what it means, because it's stable 3, you're not going to have to worry about adding extra ones to it. Yeah. Dylan, how are you?
I'm good.
Right, see? That was perfect. 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 Ah. You have too many bonds. Number 1, which is essential atom? Why do you have to not bond it? Yeah. And why are you doing 2 bonds? You don't need to do that. We don't give double bonds until you run out of electrons. You haven't even counted for one of those. I would erase it, start over, bond everything to the phosphorus, and do the accounting of the electrons down the side. That's perfect. Oh, you can't do that. Well, how many electrons did you start off with? 2, 4, 6, 8, 10, 12, 14, 15, 18. So all the electrons are equal. You didn't minus 1 or something. 3 bonds or 3 bond pairs or any combination thereof of this electron. Yep. Okay. I will draw these and go over them next day. So your homework, if you're not finished, is to go over them. Get together with another person
To do every single
and
one
check
of
them.
Or just the
Yeah, no, do all of them.
no, but like those and the advanced.
Yeah, do these too. These are good. Once you do these, do these.
Those be posted on Classroom so we can drop them down later.
It's being recorded right now.
Okay, perfect.
Yeah.
I just have a question for this one. Once I'm at the end, I've got 2 left.
You have to have everything around sulfur. That's the central atom. You can't have bonded to things. So everything has to be bonded to sulfur.